Polynomial functions. This is Chapter 6, Section 1. Some vocabulary reminding us what a polynomial is. And then we're going to talk about the leading coefficient, the degree of the polynomial, writing things in standard form, identifying and classifying by degree and by the number of terms. And then we have adding and subtracting polynomials. This is just a review because we've really been doing this for part of the school year already. All right, first definition. A monomial. So a monomial is an expression that is a number, a variable, or a product of a number and one or more variables. So, for example, 5 is a monomial. It's just a single term. Or x squared is a monomial. Or maybe you'll see something like 3xy. That's also a monomial. There's no addition or subtraction signs between. Because if there were, then that would be more than one term, so it would not be a monomial. A polynomial is the sum, indicating addition, or the difference, indicating subtraction, of two or more monomials. So when you see the pluses and the minuses in between, that's no longer a monomial, it's a polynomial. So some examples of polynomials would be x squared plus 2. You see the addition here. I'm adding two monomials. This is a polynomial with two terms. Or maybe you have something like y to the power of 3 plus 5y subtract 6. That's a polynomial with three terms. They are separated by addition and subtraction, thereby falling under this category in the definition. You're adding or subtracting two or more monomials. When polynomials are written in standard form, it means that the degrees are in descending order, highest to lowest. Like this example right here. This is written in standard form. 3 is the degree of this term. And it's an exponent. It's a superscript, if you will, if you're in Google Docs or Microsoft Word. It takes that position of the degree symbol, so it's up there, higher. Okay, so this is y to the power of 3. That's a degree of 3. This here, 5y, that's really 5y to the power of 1. So this degree is smaller than that degree. And then, of course, here, this any constant term has a degree of 0. So it's 3, 1, 0. That's standard form because it means that the degrees are in descending order, largest to smallest. When written in standard form, the first coefficient is called the leading coefficient. Of the polynomial. It's the leader. It's the very first one. The degree of the polynomial is the largest degree of its terms. So you have to be able to differentiate when we're speaking about the degree of a term versus the degree of the polynomial. For example, up here, this polynomial, x squared plus 2, the degree of this term is 2. The degree of this term is 0. The degree of the polynomial is 2. It's the largest degree of all of its terms. A polynomial in x, which simply means x is the variable that's being used, is an algebraic expression of the form a subscript of n, x to the power of n. This notation simply means this is the coefficient of this term, plus, if I'm decreasing in my order of powers, then it would make sense that I'm subtracting, right? If I'm third power and go down to second power, that's a 3 minus 1 or a 2. So this next term in the polynomial is a sub n minus 1 times x to the n minus 1 power, right? Because whatever this is, this has to be 1 less, right? If this was third power, this would be second power, or 3 minus 1. As long as I'm not missing any terms. This continues a sub n minus, well, this is in the second one after the first one, so this would be n minus 2, x to the n minus 2 power. Next would be n minus 3 times x to the n minus 3 power, or dot, 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 till we finally get down to a sub 1 times x to the power of 1. And then finally, our constant term, a sub 0. So this guy here is our constant. Okay, so it just goes in order from largest to smallest exponent till we get down to the constant, because the constant doesn't have a variable. Technically, we could write it there with a power of 0, because from our lesson on exponents, we know any number or variable to the 0 power equals 1, except, of course, for 0 itself. But if we have 5 to the 0 power, we know that's 1. If we have y to the 0 power, that also is equivalent to 1. And so that's why the constant term has a degree of 0. All right, that's the vocabulary. Now, will I ask you to write this out on a test or a quiz? No, but you should be familiar with what does this mean when you look at it. Example 1, they give us a polynomial, and they ask us to write it in standard form. So standard form means highest to lowest exponent. So you have to analyze the polynomial and figure out which one has the highest exponent. This is a second power, power of 5, power of 0, power of 4. So the power of 5 comes in first. So in this example, we see x to the 5th power, that's the highest degree. This is 2, 5, 0, 4. This would be our leader of the pack. 6x to the power of 5. You could, if you wanted to, lightly cross it off so you know that you use that. That sometimes helps as a nice visual. The next in line would be the negative 12x to the power of 4. Next in line would be this negative 4x squared. And finally, your constant, negative 3. Okay, not too difficult. This is just a review. What is the degree of the polynomial? The degree of the polynomial is 5. If you said 5, then you are correct. It is the largest out of all of the exponents. Degree is 5. And what is the leading coefficient? Well, that would be the thing that's in the very front. If there's no number there, then we know that that would be a 1. But there is a number there at 6. So the degree is 5, but the leading coefficient is 6. All right, why don't you pause the video and try the second one on your own. See what you can do with that. Okay, hopefully you paused the video and tried this one on your own. highest power is 12x to the power of 4, right? 4 is bigger than 1, 2, or 0. 12x to the power of 4. X squared is next, plus 3x squared. Subtract 3x to the power of 1. And then finally our constant term on the end, negative 10. What is the degree of the polynomial? Well, the degree is 4. And what is the leading coefficient? That's the leader of the pack right there. Its value is 12. Okay, if you have questions, you know what to do. Come into the Google Meet, post in the homework discussion, or ask a question in class. Side 2 of this notes is a little chart. It says some polynomials have special names. So here is a list of our polynomials. This one here, of course, is a monomial. It's only one term. This only has one term as well. This has got 2 terms. This one has 3. But first we're going to talk about the degree of the polynomial. The degree of any constant term, a number like 5, is 0. Because, 5 is not equivalent to 5x. But if I put a power of 0 on the x, this really means 5 times 1, because any base except for 0 to the 0 power is 1. And 5 times 1 is 5. And so this is why any constant term has a degree of 0. All right. So I guess we'll just work down by columns. So the degree of this monomial is 0. You could try to fill these in, pausing the video and coming back to it. This monomial has a degree of 3. This binomial has a degree of 1. And this trinomial has a degree of 2. 5 is a constant because it has no variable attached to it. It's a constant term. 4x to the power of 3. The degree is 3. That's classified as a cubic function. 7x plus 4, this binomial is called a linear function. The degree is 1. When the degree is 1, it's linear. And when the degree is 2, it's quadratic. We just got finished up with quadratics. Classified by number of terms. Well, how many terms does this polynomial have? It's a monomial, so it only has one term. 4x cubed. There's no addition and subtraction signs. That's also a monomial and has one term. 7x plus 4. This is the sum of 2 monomials. Therefore, it has 2 terms. And finally, the last expression in my list is a trinomial. It's got 3 terms. Fourth power. Well, fourth power would be classified as quartic. It's got this quart or quarter, all right, like 25 cents, 4 quarters and $1. This is quartic. Fifth power is quintic. And that's pretty much all we go up to. So we talk about the quartic and the quintic. Quintic, like if you have, like twins, that's 2 babies born at the same time. 3 born at the same time would be triplets. 5 born at the same time would be quintuplets. So quintic. All right, one last thing to do on this part of the notes is adding and subtracting polynomials and then simplifying them, of course. So a quick review. To add polynomials, really what you're doing is adding the coefficients of like terms. You're combining like terms. And the reason we can add like terms, never mind this. All right, so if I have something like 5x plus 3x. And this is just a demonstration to show you why you can just simply add the coefficients. They are like terms. They both have an x. And if you think about it in terms of factoring, I could factor out an x, right? Because they each have an x in common. So when I divide this by x, I get 5. And when I divide this product by x, I get 3. And it is plus. And now look, 5 plus 3 is 8. So I get x times 8, or 8x. All right, so 5x plus 3x is 8x. They're like terms. I could just add the 5 and the 3, because really what's happening is I'm factoring out an x. All right, so combining like terms, the reason why it works is right there because of factoring. What I normally do with these problems is I rewrite everything so that I have a nice list that I can combine my like terms. This here is negative 4x squared, right? There's a positive 1 out in the front here. So when I distribute the positive 1, it's not going to change the signs of anything in the group. So I get minus 2x plus 5. The same thing here. I'm distributing a positive 1. So this becomes plus 6x squared. And what I'm doing here is removing grouping symbols. Plus 2x, subtract 11. Now, it's not as, how would you say, important to remove the grouping symbols when there's addition, but when subtraction occurs, there's where we sometimes run into a problem. Because sometimes students don't change the signs of everything in the group. All right, so now I'm looking, I got to put standard form, okay? So the highest power first. Here I've got negative 4x squared plus 6x squared. When I put those together, I get 2x squared. Now I'm looking for the second power was the highest, right? The degree is 2. This is a quadratic. Now I'm looking for my linear terms, if there are any. Well, here I have a negative 2x. There I have a positive 2x. That's 0. So I'm not going to write the 0. It's silly to write the 0. It's gone. And now my constants, 5 subtract 11 is subtract 6. So that's my final answer. You could pause the video right now and try the next two. All right, so what do I got? 9x to the power of 4 plus 3x squared, subtract 24, minus 9x to the power of 4 plus x squared. Remember, I'm distributing a positive 1, so none of these signs are going to change, plus 5x plus 19. All right, now I'm going to combine my like terms. Fourth is the highest degree, and they're opposites, so they're going to sum to 0 as well, so they go away. The next highest exponent is second power, and I've got two of those terms. 3x squared plus another x squared is 4x squared. All right, now I'm looking for linear, right? I got quadratic. Now I'm going down to linear. Do I have any linear terms? Yes, I have 1 plus 5x. So I'm going to cross it off. And what am I left with? I'm left with two constants. So I've got negative 24 plus 19 is negative 5. Final answer in standard form. The last one, perhaps you have the answer already. This is 6 subtract 4x plus 17, x to the power of 3, subtract 8, x to the power of 3, add 5x, subtract 11, x to the power of 3. Now remember, all I did here in this step was to remove my grouping symbols. So power 3 is the largest, so I got 17 subtract 8 is 9, right? But then subtract 11. 9 subtract 11 is negative 2. So negative 2 of these x cubes. All right, do I have any second power? I do not. Do I have any linear first power? I do. I have two of them. I've got this negative 4x and this plus 5x. When I put those together and combine them, I have positive 1x. And then I'm looking for a constant. Do I have any? Yes, there's only one. So here I have a plus 6 because the 6 is positive. Okay, so hopefully you remember how to do this from your Algebra 1 class, and that this isn't too terrible of a skill to acquire. All right, subtracting polynomials. Now remember, all right, back to the video. The announcements were going, so I had to pause the video. Subtracting polynomials. To subtract polynomials, you're going to subtract the coefficient of the like terms. But here's, lots of stars here. You must distribute the subtraction sign inside of the parentheses. Okay, you got to do it to inside. Distribute. Okay, so the first grouping, there's not a subtraction on the outside of the grouping, so I'm just going to copy this down. And again, I highly recommend that you do this. And I know what students do. They say, oh, I'll remember to change the sign. I don't have to write this down. And then, I don't know, they make silly mistakes. All right, so this really is a negative 1 being multiplied with this. Or think of this as taking the opposite of this group. So the opposite of the group means the opposite of this, the opposite of that, and the opposite of that. The opposite of 6x squared is negative 6x squared. The opposite of positive 2x is negative 2x. And the opposite of negative 11 is positive 11. Okay, now I'm going to combine like terms. So I'm going to add these coefficients. I know we're talking about subtracting, but when you distribute the negative through, now you're just combining like terms by either addition or subtraction. This is negative 4x squared, subtract 6x squared. Or negative 4x squared, add negative 6x squared, right? If you remember probably from Algebra 1 when you had things like 3x subtract 6x was the same as 3x add negative 6x, right? So you can think of it that way. That's how I like to think of it. Negative 4x squared add negative 6x squared, that's a negative 10x squared. So you can lightly cross those off. You combine them. That's quadratic. I need my linears. Negative 2x add negative 2x is negative 4x altogether. And here I've got 5 add 11. That's 16. All right, why don't you pause the video and do the next two examples on your own. Okay, hopefully you paused the video and did these on your own. Again, what I show here is, here's the first polynomial, distributing it a positive 1 through. Here I'm taking the opposite of each one of these terms. So the first one is positive and the next three are negative. Combine my like terms. I've got power of 4 is the largest. 9 and 9 more is 18. I don't have any third power terms. I don't have any cubic. But I do have quadratic. 3x squared. Subtract x squared is plus 2x squared. Linears, that's constant. That's linear. That's constant. Negative 5x is my linear. And then negative 24 add negative 19 is negative 43. And the last one, again, I just rewrote the first trinomial. And then I took the opposite of everything in this group. So I'm going to start out with a negative, then a positive, then a negative. And here it is, a negative, then a positive, then a negative. Highest power is third power. 2x cubed subtract 1x cubed is 1x cubed. Second power would be next. I've got 5 and 8 more of those, or 13 of those. Linear, I only have one linear term, that's minus 3x, and one constant is minus 11. Okay, I think it's pretty straightforward. Last is simplify. You could, if you want, again, pause the video. Or not. I've got negative x squared, subtract 3. Nothing is changing the sign of the items in the group. But here it is. Positive 3x becomes negative 3x. Negative x squared becomes positive x squared. Negative 5 becomes positive 5. Here, I'm distributing a positive 1. So I keep all the signs. 2x, subtract 7, subtract x squared. And now I'm going to combine my like terms. I see the highest power is 2. That's got to be the leader of the pack. So I've got negative x squared plus x squared. Well, that's 0. And then here I got negative x squared. So that's all I could do with it. Negative x squared. Linear terms is x to the power of 1. 3x, that's negative, plus 2x is going to be a negative x. And finally, do I have any constants? So I have a negative 3 here and a positive 5 here and a negative 7 here. So I put these together. I got negative 10 plus 5 is negative 5. Final answer. Okay. You don't have to factor out the negative because it's not asking you to do that. If it was a factoring problem, then you would factor out the negative. Okay, you have a textbook assignment to do that goes along with this lesson. Please, if you have any questions, ask them. I can't help you if I don't know what your questions are. Okay, you have many options to ask me questions. Have a great day.